Okay, here we go. So in day 6, we're going to do our warm-up. It says that the area of a circle measures 121 pi units squared, and we have to find the number of units in the circumference of the circle, and we'll express our answer in terms of pi. So this isn't about three-dimensional shapes. This is about a two-dimensional shape of a circle. And so what they're saying is that in this circle, we have an area. So the amount of space inside the circle is 121 pi units squared. Okay? The area formula for a circle is pi r squared. Okay, and so we're going to take that 121 and put it in for the area. And so we end up with 121 pi for the area, and area of a circle is pi r squared. So the cool thing about it is there's a pi on the left and a pi on the right side of the equal sign, and then they'll cancel, and we'll just end up with 121 equals r squared. To solve for r, we're going to go ahead and take the square root, and r comes out to equal 11. All right, so the radius of our circle is 11. And now remember that they want to know what the circumference is. So going to the reference sheet, circumference is also given to us. It's called pi d. And so all we need to know is the diameter of our circle. So cool thing that we solve for the radius, because the diameter is just twice that. And so our diameter will be 2 11s. Okay, and 11 times 2 is going to give us 22. Okay, and so we'll go ahead and plug in our 22 for our diameter times by pi, and we end up with 22 pi for our circumference. Okay, and that would just be labeled in units. Circumference is just one measurement around the circle. Okay, all right, so let's go ahead and talk about the sphere. Sphere formula is given to us on our reference sheet. It's actually one of the easiest formulas, although it looks a little nasty with that 4/3 in the front. But then you got pi, and the only variable we have to sub in is the radius of the sphere. Okay. However, we have to remember that it's cubed, and that is definitely difficult for us because we're definitely used to squaring the radius and not cubing it. And so that is something we have to watch out for. Even though we write cube on our paper, when we go to type it in our calculator, we accidentally slip by habit and we square it. So be very, very careful. It'll happen to you probably if you're not careful about watching that. Okay. A couple things about a sphere. There's something called the great circle. In a sphere, it's the largest circle that can be drawn around a sphere. All right. It's almost like where the equator is when you think about the planet. Okay, so right here, if I talk about the cross section right through the middle where the equator of this, let's say, planet would be, or the Earth, that is the largest circle that can happen in a sphere. And in fact, the only cross section you can get from a sphere is a circle. You can get a bunch of different size circles, but every cross section of a sphere is a circle. Okay, so sometimes when they give you that great circle, what you can use is you can use the area of that great circle or the circumference, kind of like our warm-up. And in that case, we can find the radius or the diameter if they don't give it to us. Okay, so here we go. In number 1, it says that the diameter of a sphere is 15 inches. So there's no picture, so we'll go ahead and draw a picture. All I do is I draw a circle, and then I go ahead and I draw that kind of like that ring around it, just to give it a three-dimensional effect. Okay, so they're telling us that the diameter, okay, so the diameter of our sphere is 15, which is all the way across. Well, we don't want all the way across because like all of our other formulas, we don't really use the diameter in the formulas. Instead, we use the radius. So we're going to go ahead and take that diameter of 15, and in our picture, we're going to cut that 15 in half and say that our radius is 7.5. Okay. They want to know what the volume of the sphere is to the nearest tenth of a cubic inch. All right. So because they're talking about volume of the sphere, we go to our reference sheet. We write down 4/3 pi. Be careful, r cubed. Okay. R to the third power. We are solving for the volume, so we'll leave that open, but we can keep the 4/3. We can keep the pi, and then we already know the radius is 7.5, and that we have to make sure that we cube it. Okay. Because they said nearest in this question, everything in our formula is going to go in. So we're going to type in 4/3 in parentheses times pi times 7.5. Use your caret key to raise it to the third power. Okay. And when you hit enter, our volume is going to come out to equal 1,767.145 blah, blah, blah. Okay. Because they said nearest tenth, we're going to underline the first decimal, which is the tenth, and look next door at the 4, and it's not going to round it up. And so our volume will be 1,767.1 inches cubed. And there is our volume. Okay. All right. Number 2, it says that we have a solid sphere that has a volume of 36 pi feet cubed, and we have to find the radius. So this is a work backwards one. So again, we have a sphere, and we don't know much about it because the only measurement in it is our radius. Okay. So we'll go ahead and say volume equals 4/3 pi r cubed, and we're going to go ahead and replace the volume with 36 pi. And we'll keep the 4/3, we'll keep the pi, we're going to solve for the radius, so we'll keep it r, and don't forget to cube it. Okay. Same thing like the cylinders and the cones. When we work backwards and there's a pi on the left and a pi on the right, they'll cancel. And all we have left is the 36 here, equal to the 4/3 r cubed over here. Okay. There's 2 ways we can get rid of a 4/3. I'm going to show you guys that you could divide by 4/3, but you're going to have to make sure 4/3 is in parentheses. And I know we're not the best with using parentheses around our fractions in our calculators. So instead, we're going to go ahead and multiply by 3/4. When we get rid of a fraction, and we do this typically in algebra 2, so you might want to get used to it, instead of dividing by 4/3, we're going to go ahead and multiply by the reciprocal. Multiplying by the reciprocal is just the flipping of the fraction. So we're just going to multiply both sides by 3/4. Okay. Why this works is that 4/3 times 3/4 is really 12/12, which is 1. And 1 times r cubed is just r cubed. And so that's why this works. So this 4/3 will cancel out that 3/4. Okay. And so what we have left is 3/4 times 36, which we could then enter in our calculator. And we don't necessarily need parentheses, but you can still use them. I would. And so 3/4 times 36 ends up giving us 27, equal to r cubed. All right. And now in order to solve for that r, we have to get rid of the cube. And so if it was a square, we would square root. But if it's a cube, we have to do something called cube rooting. Okay. And cube root is a button in our calculator, so it's not that bad. All right. So we're going to go ahead and put the square root around it, but we put a little 3 here, and that's a cube root. And so if we do it on the right-hand side, we have to do it on the left-hand side. And this cube root will cancel out that cube, leaving you with r. All right. But we have to make sure we go to our calculator. It's under our math button. Okay. So hit math. And then it's number 4. So just hit 4, and you'll end up with a cube root in your home screen. Okay. And we'll put 27 underneath that cube root. And when we hit enter, we just end up with 3. And therefore, our radius of our sphere is 3 feet. Okay. All right. Let's go ahead and take a look at number 3. In number 3, it says that we have a hemispherical water tank. And hopefully you guys know that a hemisphere is half a sphere. Okay. And so when we draw a hemisphere, we don't want to draw a whole sphere. We just want to draw either the top half or the bottom half. And since this is a water tank, I'm going to go ahead and draw the bottom half of a sphere. So it almost looks like a bowl. Okay. And so this hemispherical water tank has an inside diameter of 10 feet. And as soon as you saw a diameter of 10 feet, hopefully you said, no, radius of 5. Okay. And they want to know what the volume of this tank is to the nearest cubic foot. So we're going to go ahead and write down volume equals, and we're going to write down for the sphere 4/3 pi r cubed, but we're going to put that in parentheses and multiply it by a half because it's half of a sphere. Okay. So we'll keep the half part, we'll keep the 4/3 part, we'll keep the pi part, and our radius is going to be 5, and we're going to cube it. Okay. And because they said nearest, all of this is going right into our calculator. So I would recommend putting your 1/2 in parentheses in your calculator, your 4/3 in parentheses in calculator, then your pi, then your 5, and don't forget to raise it to the 3rd power. Okay. When you hit enter, you should end up with 261.799 ... Okay. Since they went to the nearest cubic foot, and that doesn't say anything about tenth, hundredth, or thousandth, that means no decimals then. That we're rounding this 1 here for the nearest cubic foot spot. Okay, but looking next door, it's a 7, and it's going to round it up to 262, and we're in feet cubed. And there's the volume of our hemisphere. Okay. All right, I will see you guys on the back side of notes.